All right, you guys, welcome back. So we're starting second semester. One thing that's going to be a little bit different. So we got through lesson 80 in the first semester. So here in semester two, we only have to get through 120 lessons. So you remember the beginning of the year, we kind of covered some stuff very quickly since a lot of it was review and you guys were handling it really well. We were able to kind of shorten that review process. So we got through 80 lessons. We have to get through 40 in the second semester. So instead of doing 4 or so lessons a week, some weeks we're going to have 2, maybe some weeks 3, but that'll give us plenty of time to review and have a project at the end of the year. So the video recordings are actually going to be per week instead of per day this semester. So you can watch one video at the start of the week, and that'll kind of knock out that entire that item for that week versus watching it, every single day. Still have it viewed before you come to class. So if you have any questions or it's not making sense, since we kind of jump straight into the practice set problems, you'll have that ready to go. And any questions you might have, we can get those addressed. So we are looking at lesson 81. So we are doing lesson 81, the arithmetic with unit measures. So this will be Tuesday, just one lesson for the first day. So if we are looking at, recall that operations of arithmetic are addition, subtraction, multiplication, and division. So our 4 functions that we've primarily talked about. We know we have others beyond that, okay, but we have to look at this. So if we have 2 feet plus 12 inches, we can, depending on whatever is being called for, we can convert 2 feet into inches, which is 24 inches, add those two together, or we can convert 12 inches into 1 foot, which might be easier. 2 feet plus 1 is 3 feet. Okay, 36 inches is equal to 3 feet. Okay, so we just have to convert when we're using mixed measurements. 30 minutes plus an hour. Well, 60 minutes plus 30 minutes is 90 minutes, or 1 hour plus half an hour is 1.5 hours. So that's all we're doing with this. Okay, notice that in each equation in example 1, the units of the sum are the same as the units of the add-in. So the units do not change when we add or subtract measurements. So when we're adding or subtracting, 5 minutes plus 5 minutes is 10 minutes. It doesn't change. But when we're multiplying, like when we do with area, and I know we've done a lot of area, if we have a rectangle that's 2 by 3, we do 2 centimeters. We sometimes say 2 times 3, which is correct, but a little incomplete because 2 centimeters times 3 centimeters, 2 times 3 is 6, but then centimeters times centimeters is square centimeters. So that's where we get that. And so that's where we get square units. And then down the road, we'll talk a little bit about this year, but when we get to volume, we're multiplying 3 dimensions. So we get whatever our units are to the power of 3, or what we call cubed units. So if we multiply 6 feet times 4 feet, we know 6 times 4 is 24. Feet times feet gives us square feet. So we can write out SQFT for shortening. We can write out square feet in its entirety if we want, or you'll see me most commonly, I just put feet to the power of 2. That's just telling us feet squared, or feet to the power of 2. A little bit easier and probably what you see more of down the road. Now when we're dividing, okay, same concept. We divide our numbers, 25 divided by 5. We can do that, no problem. That's 5. But miles squared divided by miles, well, that's miles times miles over miles. So I have 2 of those mile units in the numerator and 1 in the denominator. So I can cancel out 1 of those in the numerator, which leaves me with 1 in the denominator, which leaves me with nothing down there. So it would be 5 miles. So we have to pay attention to units. We've worked plenty with numbers this year, but same properties as far as multiplying units or dividing or canceling out. Any units over itself cancel out, just like 5 over 5 is 1. Feet over feet cancel out to be just 1. So we have to remember that as well. So if we're doing 300 miles for 6 hours, well, how fast were we traveling per hour? We reduce by dividing or factoring out. We get 50 over 1, so 50 miles per hour. We have not gotten rid of miles or hours, so we keep them, so it's still miles per hour. If we drove 300 miles and used 10 gallons, well, what's the average miles per gallon that our vehicle is getting? We do 300 divided by 10, which is 30, and miles over gallon, so 30 miles per gallon. Or commonly, you can write it out as 30 miles over 1 gallon, or 30 miles per gallon, or 30 mpg, even as a more short way to do that. Right? So we'll look at these practice set problems when we return to class. Just remember your units. It should give most of conversions to you, but if you run into a problem, how many inches are in a foot, or foot in a yard, or meters in a kilometer, or something like that, have your reference sheet with you. That'll help you out. All right. Lesson 82, which we're going to be working on Thursday, volume of a rectangular prism. So volume is looking at a three-dimensional shape and finding the capacity. So if we're looking at a vase or a jug or something and filling it up with water, how much can it hold? That's volume, so the capacity. And we use cubic units because, as we talked about, we're multiplying 3 units together, length times width times height, or whatever the shape may be. So we're getting feet times feet times feet, or inches times inches times inches. So that's why it's cubic inches, or cubic feet, or cubic meters, or whatever it is. The book really likes to represent it and introduce it with thinking about 1 cubic centimeters or inches, or a 1 by 1 by 1 cube. I think it's an okay way to introduce it. I think sometimes it makes it a little bit more confusing. How many cubes would fit in this whatever prism? I think it's easier to just find the volume of the prism, but that's just me. If this kind of helps you visually, then it's a good thing we're going over it. So what I talked about, okay, we have a rectangular prism. Again, it's a rectangle for our bases, so top and bottom is a rectangle, and we can have triangular prisms, rectangular, octagonal, pentagonal, parallelogramal prisms, whatever. So it's just a polygon. Top and bottom are our 2 bases, or congruent polygons. It doesn't matter if it's top and bottom, or if we turn it sideways and it's left or right, it's still the same prism. So this is a rectangular prism. It's 5 by 3 by 4. So what I would do is just do 5 times 3 times 4. What is that, 60? So I get 60 cubic inches. It kind of introduces it to think about, okay, we have 5 across the bottom. We're 3 deep, and then it's up 4. So we're going to have 5 times 3 on the bottom, which is 15. Another 15, another 15, another 15. And so this is what the final thing would look like: 5 times 3 times 4. And to me, I think this looks confusing because then I'm trying to count cubes in there that I cannot see. Well, there's some in the middle that obviously I can't see, but I'm counting them. If this does help you to kind of think of it this way, then by all means, go ahead and do it. It's just down the road, it's going to be a little bit faster to just do your length times width times height and be done. But we will see some problems like this. So it'd be 60 cubic inches, or there'd be 60 1 by 1 by 1 inch cubes in there. And this is length times width times height. Should be on your reference formula. No problem there. What is the volume of a cube whose edges are 10 centimeters long? So a cube is like a rectangular prism, but it's square faces. So all the sides are going to be the same: 10 by 10 by 10. This is where I said kind of that drawing method. You can go in and draw 10 and 10 and 10 and 10 and 10 and 10, and then 10 and 10 and 10 and 10. I think by the time you have that done, it'll be an hour later and you'll have driven yourself nuts. So I would just do the calculation: 10 times 10 times 10, or 10 cubed. That's where we get the term cubed from. So 10 cubed, 10 times 10 times 10 is 1,000 centimeters. So it's 1,000 cubic centimeters. So we can write out cubic centimeters or do centimeters to the power of 3. Let me get back. volume of a rectangular prism that's 4 feet long, 3 feet wide, 2 feet high. So all the same dimensions, so just length times width times height. 4 times 3 is 12, times 2 is 24, so 24 cubic feet. That's where I said that. Exponent above my feet tells me that it's feet to the power of 3 or cubic feet. All right. Example 4, Allison put small cubes together to build larger. She made a table to record the number of cubes she used. So it's a 2 by 2 by 2 cube. We get 8 because 2 cubed is 8. 3 for the edge length. 3 to the power of 3 is 27. 4 to the power of 3 is 64. 5 to the power of 3 is 125. So if it's a cube, we can do length times width times height, but since length, width, and height are all the same edge measurement, we can just say volume is the edge or side, I think it is on your reference sheet, side to the power of 3, or edge to the power of 3. So that's if it's a cube. Let's practice set problems. We will go over those together. We'll get to lesson 83 next week. That's all we have for this week. Welcome back, you guys. It's going to be a good semester.